will be multiplying polynomials. We're going to begin by multiplying monomials together. Then we'll multiply a monomial or a single term by a polynomial. And finally, we'll be looking at multiplying binomials by binomials and polynomials. Here are some examples of a monomial times a monomial. The thing to remember for each of these is that they are all just factors. So for example, 6y cubed is 6 times y to the third power. 3y squared will be multiplying times 3 times y to the fifth. They're factors. We're multiplying everything together, which means we'll multiply the coefficients together. 6 times 3 is 18. And then we have y cubed times y to the fifth, which we know is y to the eighth. Our final answer is 18 y to the eighth. In the second example, we have 3 times 9. I'm combining the like numbers and the like variables. So we have 3 times 9 times m squared times n squared times n, and then multiplying them together. 3 times 9 is 27. M times n squared is m cubed times n squared times n, which is n cubed as well. So our final answer is 27m cubed n cubed, or n to the third power. We can also do this with fractions. When you have fractions, you just have to remember your rules for multiplying fractions. Again, I'm going to rearrange these so that we have the numbers together and the variables together. So I'm going to do 1/4 times -12. The next variable I see is an s, so I'm going to do s squared times s times s. And then my last variable is t. I have a t squared, a t, and a t squared. So I'll write that down. My final answer is the product of all of these. 1/4 of -12 is -3. S squared times s is s to the fourth. And t squared times t is t to the fifth. So my final answer is -3 s to the fourth, t to the fifth. We're simply multiplying all our factors together. In the second levels of example, we're multiplying a polynomial times by a monomial. In this type of example, we will be distributing. Well, for instance, 4 times the polynomial 3x squared plus 4x minus 8 will distribute the 4. So we'll multiply 4 times 3x squared, 4 times 4x, and 4 times -8. You know how to do this. 4 times 3x squared is 12x squared. 4 times 4x is plus 16x, and 4 times -8 is -32. This is our answer. This is the product of the monomial times the polynomial. You can do the same thing if you have more than one variable involved. So for example, 6p cubed times 2p minus q, we're distributing that very first term, which is 6p cubed. We're multiplying it times 2p, and we're multiplying it by q. So we get, we get 12p squared cubed, because we're doing 6 times 2 times p is p squared times q, minus 6p cubed times q would be 6p q squared. Here's our answer. Let's try another one. It has a fraction. 1/2 x squared y times 6xy plus 8x squared y squared. We're distributing the front factor, which is 1/2 x squared y. There's a lot of variables here. So let's multiply 1/2 x squared times 6xy. 1/2 times 6 times x squared times x times y gets 3x cubed y squared. And the second term, 1/2 times 8 x squared times x squared y times y squared. And we get plus 1/2 of 8 is 4, to the fourth y cubed. Moving along to our third level of problem, we're going to look at multiplying a binomial times a binomial. This is what you've all been waiting for, because we're going to learn something called FOIL. First, I'll show you the long way to multiply a binomial times a binomial. S plus 4 times s minus 2 is a binomial times a binomial. We can use the distributive property twice. What do I mean? Well, we can first multiply s minus 2 by s, and then we can multiply s minus 2 by 4. So that would give us s times s minus 2 and then plus 4 times s minus 2. When we multiply this out, we get s squared minus 2s plus 4s minus 8. And then we have to combine like terms. Our like terms are negative 2s and 4s. This is s squared plus 2s minus 8. So you can multiply a binomial by a binomial by applying the distributive property twice. I'd like to show you another way, however, and this is our FOIL method. We're going to do the same problem. S plus 4 times s minus 2. Now the word FOIL is an acronym, and it stands for first, outside, inside, and last. And this is talking about the position of our terms. We're going to make a nice little happy face to show how we multiply. The F for first means we're going to multiply the first term times the first term. In this case, we have s times s, which is equal to s squared. O for outside means we're going to multiply negative 2 times s, which is negative 2s. I stands for inside. Our inside terms are a 4 and an s, which is a 4s. And then our last terms. The last terms are 4 and negative 2. And 4 times negative 2 is negative 8. So we get s squared plus 2s minus 8 is the same answer. Now, FOIL is a nice trick, but it takes some practice, so let's do some more examples. X minus 4 squared. Well, we know x minus 4 squared is equal to x minus 4 times x minus 4. Using FOIL, F stands for first, so our first two terms are x and x, which is x squared. And then the O stands for outside. The outside terms are x and minus 4, which is negative 4x. The I stands for inside, so we're going to multiply the two inside terms. Negative 4 times x is negative 4x. And finally, we're going to multiply the last two terms. Negative 4 times negative 4 is a positive 16. So we have x squared minus 8x plus 16. And let's do another example. We can do an example where you have different variables. So 8m squared minus n times m squared minus 3n. Just for fun this time, I'm going to make a smiley face with my FOIL. So my first two terms are 8m squared times m squared, which equals 8m to the fourth. My outside term is 8n squared minus 3n, which is minus 24m squared n. My inside terms are n times n squared, and which is minus m squared n. And my last term is negative n times negative 3n, which is a positive 3n squared. Where's the smiley face? Well, I'm going to go to eyeball here and eyeball there, and you can see my little person. Have I simplified yet? No, I have some like terms in the middle. So I have 8m to the fourth minus, I have negative 24m squared n and minus 1m squared n. So that's minus 25m squared n plus 3n squared. I've applied FOIL and found my answer. What happens when we have a binomial times a trinomial? Well, in this case, we do have to apply the distributive property more than once. So we're multiplying polynomials of any length. And here's my first example. X minus 5 times x squared plus 4x minus 6. I'm going to multiply x times each of these terms. That's x cubed plus 4x squared minus 6x. Now for the second one, I'm multiplying negative 5 times each of these terms. And that gives me negative 5x squared minus 20x. Negative 5 times negative 6 is positive 30. Now I'm going to add my polynomials together. I get x cubed minus x squared minus 26x plus 30. That's my final answer. I'll do one more for you, and then you'll get to practice. So we're going to do 2x minus 5 times negative 4x squared minus 10x plus 3. First, I'll multiply 2x times each of my terms in the trinomial, and that gives me 2x times negative 4x is negative 8x cubed. 2x times negative 10x is negative 20x squared. 2x times 3 is 6x. And then I'm going to multiply negative 5 times each term in my trinomial. Negative 5 times negative 4x is a positive 20x squared. Negative 5 times negative 10 is a positive 50x. And negative 5 times 3 is negative 15. Add together my like terms, and I'll have my final answer. I've got negative 8x cubed, and I've got a negative 20x plus a 20x, so that goes to 0. I've got a 6x plus 50x, so that's plus 56x. And finally, I have my minus 15 at the end. Now it's your turn. I'll see you tomorrow. Thanks.